All right, let's get right into it. We have all seen this happen, right? You ask an AI a pretty simple question, and what you get back is this beautifully written, super confident, and completely wrong answer. These are called hallucinations, and honestly, they're one of the biggest things shaking our trust in AI. So today, we're going to break down exactly why they happen, and we're going to be looking at a really fascinating new research paper that says this isn't a bug. It's actually a predictable feature of how we build and test these systems.
So check this out. The researchers kick things off with a simple, almost mischievous little test. They asked 3 big AI models for the dissertation title of one of the paper's own authors. Llama here says, with total confidence, that it was efficient algorithms for learning and playing games done in 2007 at MIT. The only problem? The real title is different, the year was 2001, and the university was Carnegie Mellon. Every single detail is wrong, but it's served up like it's gospel truth.
And that leads us to the big question for this whole explainer. How is it that these systems, trained on basically the entire internet, systems that can write code and poetry, how do they get basic facts so confidently wrong? What is actually going on under the hood?
Well, what the researchers are arguing is that these hallucinations aren't some kind of ghost in the machine. They say these are the inevitable result of a 1-2 punch. First, it's about how an AI learns about the world. And second, it's about how we test it to prove that it's smart. And to really get our heads around this, we're going to use one simple analogy that the paper lays out.
I want you to think of a large language model as a student who has to cram for a massive high-stakes final exam. Their entire reason for being is to get the highest possible score on this one test. This simple idea, the AI as a test taker, that's the key to unlocking this whole mystery.
What's so fascinating here is that the AI's tendency to just make stuff up begins way before we ever ask it a question. It starts during its cramming phase, a process we call pre-training. And this is where the model is essentially born to make certain kinds of mistakes.
So, during pre-training, the model just devours terabytes of text, books, articles, websites, you name it. It's learning the statistical relationships between words. Now, it's not learning what's true or false like a person does, it's just learning which words are likely to show up together. It's basically cramming the patterns of human language.
The paper frames this whole learning process like a giant game of spot the difference. The AI learns to tell valid statements from plausible but wrong errors. So it learns that there are 2 Ds in ladder is a valid pattern, while there are 3 Ls in spell is not. But, and this is a big but, for this to work, it has to see enough examples. And that's where the trouble starts.
The researchers point to a critical weakness, what they call singleton facts. These are little bits of information that show up only once in that entire massive training data set. Think about the birthday of a sort of famous person, or a really specific detail from some obscure historical event. The model has only seen it one time. Statistically, that single data point is barely a whisper in a hurricane of other information.
And this leads to a pretty stunning number. The paper calculates that for these singleton facts, the model is statistically guaranteed to be wrong at least 20% of the time. Just let that sink in. Before we even ask it anything, the AI is already set up to fail on 1 out of every 5 of these rare facts. It's not a bug, it's just math.
Okay, so the AI is already primed to make mistakes, but that's only half the story. The problem gets put on steroids when it's time to take the final exam. That's the phase where we actually evaluate these models.
Our AI student has finished cramming. It knows a ton about common facts, but it's pretty fuzzy on those singletons. Now it sits down for its final exam, but the grading rules are, to be frank, just bizarre. They actually encourage the student to guess, even when it has absolutely no idea what the answer is.
Just look at this dilemma. You've got Model A, the honest one. It gets 8 questions right, but for the 2 it's not sure about, it just says, I don't know. Its final score is an 80%. Then you have Model B, the guesser. It also knows 8 answers for sure. But for those other 2, it just makes up a plausible-sounding answer. If it gets just one of those guesses right by sheer luck, its score jumps to 90%.
And there it is. The system actually picks the better guesser, not the more honest model. The incentives are perfectly lined up to produce these confident-sounding lies. We are actively training and rewarding our AIs for the exact behavior we call a hallucination.
And this is not just some theory. The paper points out that the most influential AI benchmarks, the very test we use to decide which AI is the best, all use this kind of binary right or wrong grading.
MMLU Pro, GPQA, SWE Bench, they all reward guessing and give you 0 credit for admitting you don't know. Our most important exams are basically designed to punish honesty.
So, if the problem is that we're giving the AI the wrong kind of test, the solution seems pretty straightforward, doesn't it? We just need to change the rules of the exam.
And that is exactly what this paper proposes. What if we change the prompt for every test question to include instructions like this one? You tell the model that wrong answers are going to be penalized. All of a sudden, guessing isn't a freebie anymore. Answering "I don't know" gets you 0 points, sure, but a wrong answer actually gives you a negative score.
The effect of this one simple change is huge. First off, guessing becomes a really high-risk strategy. Second, admitting you're not sure becomes the best move. "I don't know" is now the safe bet to avoid losing points. And third, and this is the big one, the model's incentives finally line up with the behavior we actually want: trustworthiness.
So, let's just tie this all together. We started with this problem: why do AIs lie so confidently? And we found out it starts way back in their cramming phase, where those rare singleton facts are almost guaranteed to be missed. But the real kicker is the final exam. Our tests literally reward confident guessing and punish honesty. The most powerful takeaway here, though, is that the solution might just be simple. If we want a more trustworthy AI, we have to start giving it a more trustworthy test.
And that leaves us with one last big thought. For so long, we've been focused on making AIs know more stuff. But maybe, just maybe, the real path to building an AI we can finally rely on isn't about teaching it all the answers, but about teaching it the wisdom to say 3 simple words: I don't know.